The need to develop an optical module form factor for embedded applications led to the formation of the Consortium of Onboard Optics, or COBO for short, in March 2015. I'm joined today by the consortium's president, Brad Booth, who is also principal network architect at Microsoft Azure Infrastructure. He's been presenting at the Market Focus here at ECOC. Brad, thanks for talking to us. A packed audience, I might add,
yes,
standing room only.
Yes.
One of the things you were talking about was Microsoft is looking forward to the results of the COBO work for its own data centers. Tell us why that's so critical to the company.
So when we look at how we build our data centers, there's a number of things that we have to be able to do as we move up in bandwidth. We've seen a huge change in our networks over the last 5 years even. We've seen a lot of stuff, new machine-to-machine learning, AI stuff going on, the whole IoT infrastructure starting up. Azure has a whole IoT program now focused on, bringing people's data into our data centers, then running it on machine-to-machine learning or AI to be able to pull information out of that. And so there's this explosive growth going on in the cloud data centers. And one of the things that when this happens is it drives higher and higher bandwidth. And as we go to higher bandwidth, thermal environments go up and other things come into play. So when we started looking at it a number of years ago, when we started looking out to our 400 gig generation, because we knew it was going to come, we were helping work with the standards bodies and stuff like that. When we looked at it, we said, hey, there's going to be a lot of problem here. 25 gig NRZ signaling was really tough to get to the faceplate optics. Why are we continuing to make really high power SerDes to drive to the optics, which then can go really far? Why aren't we doing shorter traces? Why aren't we bringing those modules somewhat closer to that switch silicon? And that's why we started talking to some of our partners in the industry and said, hey, what would it take to do this? And everyone's like, well, I can do you a special flavor, or I can create you my proprietary solution. It's like, no, you see, I've got to be able to have multi-sources. When we buy these modules, I got to be able to buy them from multiple vendors. I got to have good competition. We want a healthy market. I don't want to support one guy only. And so to do that, we had to form an organization that would allow us to actually have the honest discussions and work on this. We see some really good benefits in the fact that when we deal with pluggable optics, when we get the switches, they come unpopulated. And then we have to plug in the optics or the DAC cables or the AOCs. We see a fair amount of failure from just that manhandling. Anytime you have people touching equipment, you can deal with failures. Someone might touch it wrong, get an ESD failure. We joke about guys that were dragging cables, AOC cables, across the data center to go plug them in. It's like, this stuff happens. People don't think that these are not indestructible. They're in little tiny, metal boxes, therefore they're indestructible. They're not. They're pretty temperamental. And so by having humans play with them all the time, we deal with a fair number of failures from just the human contact. And the belief that if we were to buy the systems, allocate the optical modules to the switch vendors, and then they could populate them knowing already what we want in there. Because we don't change up our architecture in a generation. We have a set architecture for the generation, we have set speeds, specific types of modules we will use, and that's how it's structured. So I don't need to have that change over the lifetime of that piece of equipment. So for us, it's actually easier and probably much more reliable to have those optics populated, the switch shipped to us with the populated optics, and I just have to plug them in.
Yes, again, you said about COBO, you've now got 70 companies. Yeah. You must be really pleased with the way it's developing.
I've been extremely happy. These guys have done some amazing work. It is very interesting to see, we focus very heavily on the technical side of this organization when we formed. I previously was a founder of the Ethernet Alliance, and when we did that, that was a marketing organization aimed at supporting IEEE standards. With COBO, this was really, as much as we know the marketing work still has to happen and stuff like that has to go on, the big work was the technical specification. And, in December of last year, we formed in March of 2015, and everyone's like, well, it's taken you 2 years. Yeah, 2 years to come to a common footprint, common form factor for an industry. Like, That's massive, from a device that can take 100 gig optics in it all the way up to 1.6 or beyond terabit. That's just unheard of in our industry. So I'm glad it took us that time, because it allowed us to focus on the tough problems. It allowed people to get honest on it, and we had an awesome compromise in December of last year between Samtec and TE Connectivity on what our connector was going to look like and how that was going to work. The work that's gone on for thermal emulation, for what it takes to cable these things, the contribution is just unbelievable. I've had a number of our members come to me afterwards and go, I can't believe you got Cisco and Arista and Juniper to share the information and Ciena to share this information. We've never seen this information from them. And it's like, yeah, because they understand to be able to build these systems, they've got to talk about this stuff. This is an open system now. And when you start doing that, you start discovering, hey, I may have thought I did it right when I was in my own little bubble, but now that I've seen all this other input, I'm discovering a lot of other things that I can do to optimize or do things better. We had some good interaction with the OIF on their electrical interface. There was one of their specifications actually needed some tweaks, and we discovered that. We had some good interaction with them on the height of our module, because they want to be able to put the IC TROSA inside it. And so we accommodated their height requirement for the IC TROSA. And so, we've discussed, what's the thermal environment? What's the height of our heat sinks? How do you cable these things out? And just the information, the wealth of information there is, I think, going to be helpful to our industry in the long run.
Yes, it's all about the industry getting together. As you were saying, in those 2 years, the industry itself has moved such a long way. What for you are the sort of the next challenges and opportunities, for Kobo coming up in the next 6 months, a year or so?
Well, the next 6 months, we need to finish our spec. I think we've done the heavy lifting on our specification. To get to draft 0.4, most people want to go, 0.4, oh my gosh, that doesn't sound like you've done a lot of iterations. Well, you got to understand, 0.4 allowed us to get through all the electrical stuff, all the mechanical stuff. When we did 0, we've gone most of the problems. Now what we're doing is reviewing and spinning and making sure that we're happy with the information that we've got in there. So our target that we've set for ourselves is to have the specification done by the end of this year and make it public early next year. I think we're still on track for that. Microsoft is trusting that that's going to happen. We've already issued RFIs to see who's building optical modules for Kobo optical modules, because we know we're going to need them. We've already are working on an RFI for switches that will use Kobo modules. So we're already kind of asking the industry, when are you going to have these available? So that's the other big challenge, is getting the industry behind it, building these components, getting things lined up, getting the production to flow. Then comes the testing of it, making sure that, I know how to test those modules in isolation. I know how to test those boards in isolation, so that when the two come together, it's all interoperable. And that's going to be the key aspect of all this, is interoperability.
Well, it sounds really interesting. Thank you very much for talking to us.
Thank you.
So Kobo, bringing the industry together to guarantee the future of network architectures.